We're going to start off with a question for you. For those of you who have logged in via a browser, you should be seeing a question pop up on your screen. And for those of you on the phone, or for those of you who maybe cannot see the question on your screen, I'm going to read it to you. Just answer it for yourself in your head. So the first question is, when you turn on your faucet at home, where does your water come from? See a lot of answers coming in already. Why don't we end the poll now and then share the results? Looks like a lot of people picked public water supply well. And we got a few other ones. We got private wells. A few people don't know, which is great because that's why we're here. So here to talk more about where our water comes from is Matt Mosteller. He's environmental manager at the Acton Water District, and many of you may know him from previous Green Acton Water forums. Matt spoke at their 1,4-dioxane and PFAS forums, and he did such a good job where he invited him back. Matt, can you give us an overview of where our water comes from?
Great, thanks, Norm. Are you going to bring the slides up?
Yeah, I think that has to go.
Yeah, hang on one second. Is the poll pulled down?
Yes, the poll is down.
For some reason. There we go. Sorry.
Okay.
There we are. Thank you. Appreciate it, Norm. So starting from our first poll question, I want to explain how you get water in Acton and some of the history behind that. So here we have a map showing Acton. And back in April of 1895 was the first time that the town really started to think about water. They appointed 5 citizens to do a study, examine possible sources, estimate how many water takers there might be, develop a proposal for a water system, and then report back to the town. And one of the questions that comes up quite frequently is, we have this great pond here in Acton, and on my map you can see a blue area, and that's Nagog Pond. And one of the conclusions of this study back in 1895 was that Nagog Pond wasn't actually a suitable water source for Acton. And that largely had to do with the lack of good pumping technology at the time to get the water from where it was to where the people needed it. So that's how we kind of ended up not using Nagog Pond. Second, a lot of people wonder, and I was surprised we didn't see this in the poll results, about getting water from the Quabbin Reservoir. And unfortunately, we're just too far away from a point that we could get water from that Greater Boston water system. So here, the other thing that I want to highlight to folks is there's pink areas on this map, and it kind of shows you that water resources as a whole isn't just localized to Acton. It really is a regional thing, and I think you'll hear other speakers talk about that as we move along. Next slide, please. So a little bit about the Acton Water District. So 1895, it took us a little while to actually get a water system. We were chartered in 1912. The district is an independent municipal entity tasked with supplying domestic water and fire service to a majority of the town of Acton. So talking about, kind of where we get our water from in Acton, we are the primary water supplier in town. About 95% of properties are served by us. The remaining people either have a private well. Some of you answered that question. About 3% probably in North Acton, out Newtown Road, or up near Pope Road and Strawberry Hill. The other folks are either part of another public water system. There are 3 standalone public water systems in town still, and the town of Concord serves about 70 properties in town. So as our system grew over the years, we started out just serving a small portion of town. And then in 1962, we were chartered to provide water to all of Acton. And we do that through a lot of different pieces of infrastructure, and I'm going to run through those, but I just want to note that we are a highly regulated industry. We have oversight from the federal government via the EPA, from the state government by Mass DEP and the Department of Public Health, and even by our own local Acton Board of Health. So where does our water come from? It comes from 23 groundwater wells currently. And we'll talk a little bit about that. And the thing about a groundwater well is it relies on the underlying aquifer. So that's water that's underneath the ground surface. And I believe Erica will talk a little more about that. And I just want to point you all to the map that I have shown here, which shows groundwater protection zones here in the town of Acton. And really that is kind of looking at the criticality of the land uses and what's going on as you get closer to our wells. So these 23 wells go into 4 treatment plants throughout town, and they all have different kind of goals that they're trying to meet. The number one thing we do is try to provide healthy water. So we're trying to prevent acute and chronic public health concerns. We're trying to make sure the water is safe so it doesn't harm you when you use it or consume it. And we're also trying to make it aesthetically pleasing. Most people think water is clear, and that's our goal, is to try to make it look clear. The next piece of our infrastructure is our water mains. We have about 135 miles, anywhere from 2 inches up to 16 inches. We have 4 storage tanks that have about 8.5 million gallons of storage. And this is to provide pressure to our system, to provide fire protection, to meet peak demands, and also to make sure that our system can be reliable if any of our treatment plants need to go out of service. Finally, I want to talk about how much water we use. We currently have a permit from the state of Massachusetts that lets us use up to 1.94 million gallons a day on average. Over the past 5 years, we've been using about 1.5 to 1.55 million gallons a year, with a peak demand at about 2.3 million gallons a year. And our system is designed to really work around 3.5 to 4 million gallons when it's at peak performance. Next slide, please. So what am I talking about? I mentioned the word well. A lot of people might be scratching their head going, I think I've heard of a well, but what is it? What actually is it? So here we have a photo of one of our Conant 2 wells. And basically what a well is, it's a pipe that goes into the ground. Down at the bottom, there's a slotted screen, and surrounding that is what we call gravel packing. And what this does is it keeps the material in the aquifer from getting into the well, and it keeps a nice transition so we can pull water into that column and then pump it up to the ground surface. Here in Acton, our wells are anywhere from 28 to 65 feet deep, which is relatively shallow. That's good because we can get recharge when it rains and the snow melts. It's easy to extract the water. Unfortunately, it does make it somewhat susceptible to contaminants, and it can also be susceptible to drought. One thing that we've been doing is exploring deep water aquifers, and these wells that we're looking at would help with our resilience, and those are about 600 feet deep. Next slide, please. I'm going to wrap up with some photos just to keep us moving along here. We don't have much time. So on the left side of the screen, there's just 2 examples of water main material. So the one on top in that photo is a concrete pipe that was very popular in the 50s and 60s. And under that is a brand new ductile iron pipe, which is our new standard. In the middle, we have 2 pictures of treatment plants. The first photo is using a membrane filtration, and the second photo with the blue vessel is using a media filtration. And then the final photo here is one of our storage tanks. I chose this one. This is our Great Hill tank because that's been in service since the inception of the Acton Water District. And that's an old riveted steel tank that we've been taking good care of. Last slide, please. So this is just a map of our system. The colored lines represent all the areas that we serve water to. The yellow boxes that you see represent our facilities, our tanks, our wells, our treatment plants. And this just shows you a visual of the presence that we have in Acton. The value, the depreciated value of our system is close to $63 million. And we have about 400 acres of land that we own and manage that's all part of this. So I just wanted to highlight kind of our presence and kind of the magnitude of what it takes to get water from the natural environment to your homes. Thank you very much, and I'll pass it back to Norm.
Thanks, Matt. That was great. Matt, so it's we use about 1.5 million gallons a day, right?
That is correct.
Yeah, so that's a lot of water being pumped out of our wells. So it's time for another poll question. Here's a picture that Matt gave us. This is a 2 million gallon water storage facility, tank, whatever. So we're using a lot of water. So our next question is, how do these wells get replenished? Oh, you can pick more than one for this as well. All right, looks like a lot of answers are coming in. Why don't we, got a few more seconds here. A few are coming in. All right, so why don't we end this poll? Okay, so we just heard from Matt from the Acton Water District. And as many of you know, and Matt mentioned, the Acton Water District is a municipal entity. It's completely separate from our town government. But like the town government, it has staff, including Matt, and it also has elected officials called water commissioners. To discuss how our wells get recharged, we're going to hear from one of the three commissioners, Erica Amerlin. Erica, being a hydrogeologist by profession, will help us understand how the water gets into our wells.
All right, great. Thank you, Norm. Perfect. Yep, so as a follow-on to Matt, since we know now the infrastructure that gets us water, I'm going to talk a little bit about groundwater recharge and protection, since all of our wells are pumping groundwater, and that's entirely what we're drinking in Acton. The sign on the right here, you may see these around town, you may see them in other parts of Massachusetts, and these indicate areas where we're trying to be extra careful of protecting our water supplies, and I'll talk a little bit about that at the end of my presentation. Next slide. Okay, so as Matt really nicely outlined, the drinking water in Acton is pumped out of wells, and the water that these wells access comes from an aquifer. And an aquifer is an underground layer that's holding water. Our aquifer is made up of sand and gravel, and our sand and gravel deposits were left behind by the large glaciers that once covered Massachusetts not so long ago. Groundwater is found in the millions of tiny spaces in between the grains of sand and pieces of gravel that make up these deposits. And each of those tiny spaces is connected to many, many other tiny spaces, and that creates pathways through which water flows in the ground. The dry area above the aquifer is called the unsaturated zone, and that's not the right place for a well because there isn't any groundwater there. Below that is what we call the water table, and that's the depth below the ground where we first encounter the saturated zone, the place where all the spaces between soil particles are filled with water. In some places, the water table is right at the ground surface, and in those places, we see bodies of water like wetlands, ponds, lakes, streams, and collectively, those bodies of water are known as surface water. Next slide. So Matt alluded to this, groundwater in our aquifer is replenished by precipitation. We have a shallow aquifer, and we are pretty much dependent on precipitation of all kinds for our water. So when rain falls on the ground or when snow melts, not all of that water actually goes into the aquifer. Some of that water is used by growing plants like trees and grass. Some of that water evaporates. Some of the water runs over the land surface into surface water bodies like streams and ponds, and some of the water that falls as precipitation does seep into the ground and reach the aquifer. So recharge is all the precipitation, which makes it all the way through the ground into the aquifer. Recharge is happening at different rates at different times of the year. When plants are in full leaf during high summer, a lot more of our rainfall gets used by the plants before it can make it into the aquifer. Times of the year like fall or late winter, when plants are not making leaves, more water is reaching the aquifer. And in places where there's a lot of impermeable surface, like large parking lots, more rainfall ends up as runoff. So it's running off the land surface and is going into surface water bodies or stormwater instead of into the ground. In some places, some of this water is in a wetland, a pond, or a stream, but it has a connection to the aquifer. So we may actually be gaining water in our aquifer from surface water. The groundwater and surface water is a connected system. Next slide. So, as I mentioned before, we have a shallow aquifer. It's relatively close to the surface of the land. Matt mentioned some of the advantages and the disadvantage, which is that it's easier for contamination to reach our aquifer. There are a number of threats that we deal with along with other folks who have shallow aquifers. These include contaminant releases such as a leaking underground tank or a spill from a vehicle, industrial activity, including poorly managed chemicals and waste products, improperly treated sewage, agricultural drainage, which can include herbicides, pesticides, and large amounts of fertilizer, stormwater, improperly managed stormwater, as I said before, runs off the land, doesn't make it into the aquifer, and can carry contaminants from roads and parking lots with it. And then landfills, which are all over. Some are new, some are old. And landfills previously were unlined. They had no bottom. And so anything that collected in the bottom of a landfill, which is called leachate, could go directly into the aquifer below it. Newer landfills have liners, but those can become damaged if they're not properly maintained, and the leachate can leave. And in those cases, people may not even know that it's left the landfill. All right, can you advance, please? The good news is there are a number of protections and controls that can be implemented, and in many cases are implemented to mitigate the effects of these threats. Pollution source control is a really, really powerful tool, because if it doesn't make it to the aquifer, then we don't have to clean it up, we don't have to treat for it. So that's the ideal situation, is to never have contamination enter in the first place. Strong environmental regulations are also really important. And as Matt talked about, we're regulated at a number of levels. Environmental regulation can come at the local level, the state level, and the national level. And each of those creates a layer of regulation and protection for how businesses that might contaminate us can operate. Proper wastewater treatment is an important mitigation at all levels. So small, large, different kinds of systems. Properly treated wastewater is much better for the environment. Fertilizer and pesticide reduction programs. These are generally implemented in conjunction with farmers, and it reduces the amount of pesticide, herbicide, and fertilizer running off of fields and entering the environment. Stormwater management, including updating stormwater infrastructure to deal with some of the rainfall changes we've seen. Tim's going to talk a little bit about rainfall and how storms are changing over time in terms of the amount and type of rainfall we get. Stormwater infrastructure needs to adapt to that. And then land use control. Remember, we talked about recharge. Water needs to make it into the ground. It needs places where it can make it into the ground. Green places, protected places where we'll get good recharge, where the water's not going to pick up a lot of contamination along the way. And now I will hand it off to you, Norm.
Thanks, Erica. That was great. It seems like the flows in our aquifer are fairly complex. It's probably hard to understand it all. So you talked about the major aspects of recharge, and one of them being precipitation. So that's going to be our next poll question for you. How much precipitation do you think falls on Acton each year on average? And for so we're going to consider both snow and rain here. And so for snow, consider a foot of snow equal to about 1 inch of water, or so 1 inch of precipitation. So, okay, it looks like we have a lot of answers are coming in. All right. Okay, a few more seconds here. Get your answers in. Okay, why don't we close up the poll? And so it looks like quite a variety of answers here. So to tell us more about to answer the question and to discuss historical precipitation patterns in Acton, we're going to hear from Kim Cassis. Kim is an emeritus professor of Earth and Environmental Science. She's also the chair of the Green Acton Water Committee, which is a citizens environmental advocacy group. And Kim is also one of the primary creators for this forum. So thanks, Kim. Why don't you let us know how much rain we get?
Sure. Could you tell people what to do if they have questions, though?
Oh, I thought I did, but maybe I didn't. I'm sorry. So we're going to have a Q&A at the end. And so if you have questions for any of the presenters, for those of you online, you can enter them in the Q&A, okay? And for those of you on the phone, or if you want to enter them not in the Q&A, you can enter it. You can send an email to watercontact@greenacton.org. So water-contact@greenacton.org, and Green Acton is one word. So questions, so you can start putting in questions for that. Thanks for that, Kim.
Okay, next slide. So the answer to the poll question is that Acton gets each year approximately 48 inches of rain, or 4 feet of rain. If all that were to fall in a swimming pool, it would be chest high on me up to about here. And so some of you are underestimating a bit, but let's see. As Eric and Matt have explained, all of the public and private water supply in Acton comes from wells within our area. So could you advance the slide, please? We are not like, Los Angeles or New York or Boston, where we draw our water from a distant hinterland. All of our water is local. It comes from the water that falls from the sky locally. So this is a map of Acton with the boundaries of the town in red. In light blue are the network of streams and brooks that cross Acton, the Neshova Brook system in the north and the Fort Pond Brook system in the south. And these tributary systems have their headwaters in the adjoining towns, but not very far away from us. Now I'm going to superimpose. Can you advance the slide? The magenta shapes superimposed on the map are the water protection zones, the same ones that Matt showed you earlier. And as Matt mentioned, the water protection zones also cross the town boundaries. And another thing to notice is how the surface streams feed into the water protection zones, into the recharge zones. So up here into the recharge zones for the North Acton wells, and then down into here to the Central Acton wells, and so forth. So the take-home message from this map so far is that our water supply is very local. So we have these 48 inches of rain approximately that falls within the boundaries of our town and a little bit into our near neighbor towns. And that's all we've got to work with, is just what falls from the sky locally. Let's see the next slide, the next advance the slides. So 48 inches per year on average is a pretty generous amount compared to many parts of the nation. So we're here in this aqua region, indicating we get between 40 and 50 inches of rain per year, which is, we're doing very well compared to the people out here in the yellow, brown, and red areas who get less than 20 inches of rain a year. However, let's look at the next slide. As it turns out, many years are very far from average, and we can't really plan for our water usage or our wastewater disposal based on assuming that each year will be near to the average. This is a graph showing water in precipitation in Massachusetts for 100 years, spanning from 1921 to 2021. And the colors indicate in blues and greens the years that were abnormally wet, in yellows and reds and browns, the years that were abnormally dry. And there are not all that many years that are close to average. We have a very volatile precipitation pattern here. Advance the slides. So we have some very wet years like last year. We have some very dry years like 2016. Next slide. And every now and then we get a multi-year severe drought like we had in the 1960s. I can so clearly remember my 6th grade teacher telling us kids that we needed to conserve water because we were in a terrible drought. That I now understand was the big drought of the mid-1960s. So the take-home message from all of this is that the precipitation in our region is volatile, very changeable from year to year. So some years are near average, but many years are much wetter or much drier. So that in planning for the future, in terms of water supply or stormwater handling or wastewater capacity, we need to plan for not just the near average years, but also for the high precipitation and low precipitation that nature will have in store for us. Thank you very much, and back to you, Norm.
Thanks, Kim. That was great. So historically, we've seen some wide fluctuations in precipitation patterns, and currently we're in a wetter phase. But this spring, we've already seen some droughts around the state. Yeah, so it's kind of interesting. So what does that portend for the future? So that leads to the next poll question. What What climate change models, what do you think climate change models say about precipitation in our region? You can select as many answers here as you think are appropriate. So see some answers coming in. Okay, why do we wrap up the poll? Oh, a few more seconds. Okay. So it looks like we have several areas selected. So just to discuss what the climate change models are saying, we're going to hear from Acton Sustainability Director Andrea Becerra. As many of you may know, Andrea is overseeing the development of the town's climate action plan in response to the emergency declaration passed in the 2020 town meeting. Andrea, what do you see the models saying about our region's future weather patterns?
Hi, everyone. Thank you for having me here. It looks like a lot of you got some of this right. We are expected to see more frequent droughts, but also more frequent torrential rains. So I'm Andrea Becerra. I'm the Sustainability Director for the town of Acton. So today I'm going to be talking about what our climate models say about the future of water in Massachusetts and what this means for resiliency planning. So next, please. So in 2018, we completed a municipal vulnerability preparedness plan to identify the major hazards in Acton and plan for addressing them. So the top 4 hazards identified in this report were flooding, severe storms, drought, and extreme heat. So the graphic that you see here came from our MVP planning process. So the general pattern is that rising temperatures are expected to melt snow earlier in the spring and increase evaporation, and this will leave us with drier soils during summer and fall. Flooding is also likely to be worse during the winter and spring, and droughts worse during the summer and fall. So more tangibly, what does this mean for our water? So extreme weather events like severe storms and flooding, which are predicted to increase due to climate change. And as Erica mentioned earlier, severe storms can also carry pollutants to our water. So all of this has a direct effect on our water quality. So the US National Climate Assessment reports that between 1958 and 2010, the Northeast saw more than a 70% increase in the amount of precipitation falling in very heavy events. And current models found that predict a continued climb in our annual precipitation, which can be found on the MA Resilience site, which is tracking these future predictions annually. So when it comes to heat, climate change models predict that Massachusetts will continue to experience an increase in the number of days over 90 degrees Fahrenheit during the summer season. So for example, between 1971 and 2000, Massachusetts averaged 5 days per year where temperatures exceeded 90 degrees Fahrenheit. Climate scientists project that by mid-century, the state could have a climate that resembles the southern states today, with between 10 to 28 days over 90 degrees Fahrenheit. By the end of the century, extreme heat could occur between 13 to 56 days during the summer. So I should note, last year, Boston saw over 24 days with temperature of 90 or above. So what does this mean for water? As I mentioned earlier, rising temperatures will melt snow earlier in the spring and increase evaporation, leaving us with drier soils during the summer and fall. Drier soils are harder to replenish with water, which can decrease infiltration and reduce groundwater recharge. So even though climate change is predicted to bring more annual precipitation concentrated in the winter and spring, the models also expect there to be more drought. So what does this all mean for climate planning and resilience? So resilience is the ability of a community to address the needs of its built, social, and natural environment in order to anticipate, cope with, and rebound stronger from events and trends related to climate change hazards, like the ones I mentioned earlier: flooding, extreme heat, storms, and droughts. So I'm not going to dive into this diagram due to timing, but I'm happy to do so if there are any more questions about mitigation versus adaptation and how that plays into resiliency. Next slide, please. So what does this mean for resiliency planning for the town of Acton? So here I've highlighted 3 different buckets of solutions, some of which have already been mentioned. earlier today. So continue improving ways to manage stormwater and protect water quality is a really important one, and one that's directly in the town's purview. So as I mentioned, floods can transport pollutants into our wetlands, water bodies, and groundwater. So one of the important roles for the town is to ensure proper stormwater management, which includes educating the public about things such as minimizing fertilizer use, picking up after dog waste, keeping the storm drains clear, not littering, and preventing things like oil leaks in your car. Second, continue promoting best practices with development. So on the right, you see a depiction of sustainable landscaping. So things like bioretention sites, such as bioswales or rain gardens, can help capture our rain, clean our water, and replenish our groundwater. They're also really beautiful and promote biodiversity. So it's a win-win. And finally, continue to plan for the future. So in the middle is a picture of our municipal vulnerability preparedness planning I mentioned from 2018. And we're about to begin our hazard mitigation planning process, and we're due to begin our MVP process at the beginning of next year. And finally, we're also finishing up our climate action plan, which includes goals and actions that directly address water, and includes an action to continue coordinating with the Acton Water District to promote best water management practices. Thank you.
Hi, Andrea. That was great. Thanks so much. So far we've been talking about Acton's water supply as a whole. For the next set of topics, we're going to look at Acton's water from an individual perspective. So our next poll actually has two questions. And the first question is, approximately how much water do you use per day? And the second question is, what do you use most of the water for? So pick your top two on that one. So I just want to make sure too that remember there's a scroll bar on the right side of your window. If you can scroll up and down, I'm sorry, not the right side of your window, the right side of the poll question. And you can also expand it some by pulling it out. So you can see it to help you see both questions. Okay, a lot of good answers coming in. A few more seconds. Okay, why don't we close up the poll? All right. A lot of choices here, a lot of answers spread out. Here says here somebody chose ice for cocktails. That's great. If you can invite us all to your next party, that'd be awesome. So far we've been let's see. To discuss individual water usage, we're going to turn to Lucy Kirshner. She's a member of Green Acton as well. She's a member of the Green Acton Water Committee for several years. And her interest in Acton's water has been met by attending monthly Acton water meetings, Green Acton water meetings, and by going to many of the bi-monthly Acton Water District Commissioners meetings. As I mentioned earlier, Acton Water District is similar in structure to the town government, and the Acton Water District has annual meetings, which are equivalent to the town meetings, where the public is encouraged to attend and vote on some critical issues. Back to our presenter, Lucy is also a primary creator for this forum. Lucy, what have you learned about personal water consumption?
Oh, great. I'll get that next slide. Thank you. It was fun to see all the choices that you put for how much water use you use as an individual, because in fact, good data from Acton Water District shows that citizens in our town use on average 55 gallons of water each day. And that may seem high for you, but recognize that this is average and average over a year. So there may be days you don't use so much water, maybe that's more in the winter, and another day when you might use a whole lot of actual water. So the average use of water per day, per person, is way up to 55 gallons of water. And just to make it a visualization for you here, this picture is of a 50-gallon water barrel and a couple of water in the containers beside them. And that would be 55 gallons, about the amount that one person would use each day. The it's actually 55 gallons is very low compared to many places in the country. The average for the state of Massachusetts is low for the whole country as well at 65 gallons. So we have been quite efficient with our water use in Acton. Now, the next question was what you do with that water you get. So if I can have the next slide, please. Now for the second question, what do we do with the water we get? These are data from the Water Research Foundation's residential end uses of water. And this is for the whole country. So who knows how close Acton's use or your own use might be. But you'll see across the country, the largest piece of this pie is the outdoor watering. Almost 30% of people's water use goes to outdoor watering. I will say at this time that at our house, we use 3 of those water barrels that I showed you in the last picture, catching water off our roofs. And that does enough to water our gardens so we don't have to count that in our home use. Now, the next heaviest use seems to be the toilets, but followed very closely by showers and baths. Many of you said showering might be the highest in your house. And then there are faucets in kitchens in the bathroom and washing clothes that are all pretty much the same size of how we use our water. You may be surprised with the large piece of the pie that is about leaks. But according to the EPA, about 1 out of 10 homes in the country can have a leak that can use up to 100 gallons of water a day. So leaks is really something to watch out for. I want to put my attention to that very skinny little slide or the slice on the pie for dishwashing. Only 1% of the water we use usually goes into a dishwasher, which is very efficient, although of course, efficient in water, maybe not efficient in energy. So I would say that as we think about exactly how much water we use, you want to consider that efficiency and see whether you might be able to or interested in even more conservation. And so let's turn to the next slide and go on with this.
Thanks, Lucy. That was a great overview. And it was interesting to see just the variety of numbers that the people had picked for how much they thought they were using, and then see what the average really is. You discussed the many ways in which people use water, and that gives us some insight into the ways we can conserve water. As you mentioned, Acton does a pretty good job of conserving water, and likely many of the folks in attendance are concerned about water sustainability. So our next poll question is related to that. And the question is, what are the most compelling reasons for you to conserve water? And I answer as many as apply to you. And again, there's no right or wrong answers here. It's more about your areas of concern and why you conserve water. A lot of quite answers here to choose from. And don't forget the scroll bar on the right, because there's several here. And we'll give you a little bit more time on this one because there's a lot to read here. So. And again, you can pick more than one answer here. Just whatever is important to you. A lot of reasons coming up. Okay. Why don't we give it about another 5 seconds and then wrap this up? Okay, why don't we close it up? Yep. And seems like people have a variety of reasons for conserving. And to discuss this, we're going to turn to Alex Wallstrom. Alex is the environmental analyst for the Acton Water District. Alex has over a decade of experience with both water quality and conservation. Alex, can you tell us what some of the reasons are to conserve water and different resources on ways to conserve?
Absolutely. Thanks, Norm. So it's very interesting for me to see the poll results. And I definitely like to take an opportunity to dig a little bit deeper into some of those reasons that you all selected for why conserving water is important to you. Next slide, please. So of course, using less water can have a financial implication. It can translate to savings on your water bill, which might feel especially important now in these days of rising costs for food and fuel and energy and all of those types of things. One reason that I was surprised to see a lot of people answer was the connection between water conservation and water quality. So when we conserve water, that gives us here at the Acton Water District some flexibility to optimize our source operations. So we can prioritize the use of wells that have lower concentrations of different water quality constituents. So you all may be familiar that there are wells that are impacted by PFAS, 1,4-dioxane, and some of our wells just have higher concentrations of what we would consider nuisance minerals, like iron and manganese, that can cause just a color or a taste to the water. So when there's less water use in the system, we can rely more on those wells that are less impacted by those constituents and reduce the frequency or the flow rate of wells that are more impacted by those things. When there's reduced water usage, that also provides less wear and tear on our pumps and motors at our wells. And it can provide us with an opportunity to complete sort of routine preventative maintenance at our facilities, which can ultimately increase the longevity of our existing infrastructure. You know, as Andrea discussed, there is an expectation with a changing climate that there will be changing precipitation patterns. So we can expect, you know, periods of drought conditions. And when we're reducing our water usage, that can, you know, increase our preparedness for those drought conditions and just make us more resilient in the face of a changing climate. And of course, the environmental stewardship, I think that's a big piece of most of what motivates a lot of us that are on this call, just trying to balance both the human need and the environmental need for water. Next slide, please. So now we're all feeling super motivated to use less water. So let's get into some of the resources that are available to help you accomplish that goal, and we can all achieve some results. So of course, here at the Acton Water District, we have a number of different rebates that are available. So we have rebates available for WaterSense labeled toilets, faucets, and shower heads. We also offer rebates for high efficiency clothes washing machines. We have a number of different water saving devices that we give away for free. So if you'd like to try a high efficiency shower head, or you'd like to use a rain gauge to see how much rain you're getting at your specific property, we have those available. You can come down and visit us and pick one of those up, or we'll be at the Climate Festival on Saturday if you want to come visit us there. Of course, we have lots of resources on our website, so you can certainly check that out. You may be familiar with our WaterSmart platform. That's a tool that you can use to view your water bill. You can take a closer look at when you're using more water seasonally. That tool can provide you with some you know, tailored recommendations for how you might be able to reduce your water usage. And it can even inform you if we think that there's a leak at your home. We do have a water use restriction program. I'm sure you all are familiar with that, the odd even day, and the particular focus on lawn watering, which is really a big chunk of that 30% of outdoor water usage that Lucy referenced. So kind of focusing restrictions on that, which makes up a good chunk of that outdoor water use. Another program that's relatively new is we're offering free efficiency evaluations for our residential customers, which would be an on-site visit to your home where we can go over some of the rebate programs that we have in town and again, do some customized suggestions for how you might be able to reduce your water usage. Next slide, please. So we've thrown around the word conservation, efficiency tonight. So I want to kind of talk a little bit about the difference between those two. So conservation really kind of refers to behavior-based strategies to reduce your water usage. So think about turning off the tap when you brush your teeth, or reducing the time that you're taking a shower, or only running your clothes washer or dishwasher when you have a full load. So those are conservation based. They're really targeting changing your behavior to reduce your water usage. Now, when we talk about efficiency, that's really improving or rather reducing the amount of water that we need to use to accomplish a task. So you can see this chart here on the left. The font might be a little bit small, but this is kind of looking at different water using features in your home and how their usage changed over time. So when we look at toilet usage in 1999 and clothes washer usage from 1999 to 2016, you can see that there's a pretty significant reduction. Now, that's not because we stopped flushing the toilet or we stopped washing our clothes. That's really just because the efficiency of those fixtures greatly increased. So instead of, you know, a vintage 1980 toilet that might have used 5 gallons to flush, you might have a newer model now that only uses 1.28 gallons to flush. So really just reducing that amount of water that's being used for a task. So we have behavior-based strategies and just improvements in technology. So we need to put those two together to really maximize reductions in water usage. And then you can see this chart here quickly on the right, which shows you the bars are going to show you average daily water usage. So we talked about that a little bit earlier. On average, we're looking at about 55 gallons per day, as Lucy mentioned. And then that line at the top of the graph is showing you the number of service connections that we have here at the district. And so you can clearly see over the last 5 years, water usage on average by our residential customers has stayed pretty much the same on a daily basis, despite the fact that we're adding additional connections. So that kind of will point to the fact that our customers are using these conservation and efficiency strategies, and they're using their water more wisely, despite more customers joining the district. So with that, I'll hand it back to you, Norm.
Thanks, Alex. Very interesting, the difference between efficiency and conservation in terms of two modes of conserving water. You mentioned that Acton Water District has stuff on their website. We're going to be posting later on in the forum. We'll be posting links to all the different groups here, like different organizations, including Acton Water District, So, and that will also be on the Green Acton website for those not on the phone, and for those of you on the phone. One more reminder: if you have questions, we see questions coming in for the Q&A session. Those can go into the chat or water-contact@greenacton.org. So let's continue on. So Alex just talked about the need to limit water use based on the fact that it's a finite resource. And so just as potable water is finite, our capacity to cope with wastewater is finite as well. So our final poll question is around wastewater. And again, this poll question, this part of the poll has 2 questions as well. So again, use that scroll bar to answer both. So the first question is, when your water goes down the drain, where does it go? And the second question is, for those of you who have a private septic system, when was it last pumped? And if that last question doesn't apply to you, just skip it. So. Okay, a lot of answers coming in. Okay, why don't we give it about another 20 seconds or so? All right, so why don't we end the poll? So it looks like most people picked a private septic system, but a few other choices shown as well. Nobody picked a composting toilet. They must not have shown up tonight. So to discuss this topic, we're going to have Michael Geis, a chemist and a member of the Water Resources Advisory Committee. commonly known as RAC. You may be more familiar with that name. So RAC is a town committee composed of Acton residents appointed by the select board. RAC advises the select board on the protection of Acton's water resources. Mike, can you tell us a little bit more about Acton's wastewater handling?
Sure enough. Thanks, Norm. So the first slide we have, where does your wastewater go and what do you do with it? Well, there's two solutions. One, you can have somebody haul it off and treat it for you. That's considered a sewer. Or you can take care of the responsibility for yourself, and that would be a septic system. So I'll be talking about how septic systems and sewers operate and how to maintain your septic system. Oh, next slide, please. So here we have the sewer. Now over on the left, we have the grayed areas where the town sewer is, and the town sewer treatment plant is way down here on Adams Street. So the treatment plant, the sewer treatment plant, has to do several things. It has to remove pathogens, has to remove nitrogen, either in ammonia or a nitrate form, phosphates, and some other things which I've neglected to put here. And how does it do that? Well, first off, it takes all the different sources of wastewater all over through this dark area and pumps them all down to this little spot down here, the Adams Sewer Street treatment plant. Once it shows up there, they take the wastewater and they ferment it in a cycle of aerobic and anaerobic environments. And what that does, cycling through that burns out the nitrogen. Basically, they take the oxygen away and then add it to it. And that burns out the nitrogen, so it's no longer there or a burden for the environment. You still have solids now, and you have the phosphate. And it's what we do, and what the sewer does, it adds aluminum salt to that. And that causes the solids to precipitate and also bind the phosphate to the solids. So this forms the sludge, the sewage sludge, which is pumped out and taken to a landfill or used for fertilizer. Now, the aluminum makes the water acid, and so you have to adjust the pH. Once you've done that, you filter the water again to get any less solids out, and then you disinfect it with hard UV radiation. At that point, you can leave it out into the environment in a rapid filtration bed, which is very much like a septic system, leaching field. So you can see there's a lot of steps here, and they can go awry. So you have to have a personnel there operating the system all the time to make sure everything moves smoothly. Now, for the next slide, please. For the septic system, the philosophy is entirely different. There is no personnel there, and we use natural solutions to take care of the wastewater properties. And so a septic system consists of two units. One is a septic tank, and then on the right, there's a leaching field. So the tank, you flush things into the septic tank from your house. The solids fall to the bottom, grease and oils flow to the surface, and you suck the water off in between these two layers, the clean water, and you take that over to the leaching field where the miracle happens. And so in the septic tank, you have fecal E. coli on the order of 250,000 colonies per 100 milliliters of water. 100 milliliters of water is about half a cup. Because of when you take it over to the leaching field, because of the bacteria and the air that's in the leaching field, the colonies are reduced to about 10 fecal E. coli, 10 fecal E. coli for 100 milliliters, which is equivalent to most sewers. The other component you have to remove is ammonia. Now, ammonia is toxic to us, but it's very toxic to fish and aquatic life, and that can't be put out in the environment. So you, once again, take it over to the leaching field. The bacteria and the oxygen there, once again, takes the ammonia, turns it into nitrate. Now, nitrate is really innocuous. It's not toxic. But however, that still has problems. And eventually, on the order of months, that nitrate will turn into nitrogen gas. And so you see over here, we have a leaching field, and I have this plume of nitrate that's flowing out away from the leaching field. The real plume may be several hundred meters long as the nitrogen or the nitrate is being decomposed into nitrogen gas. The other component we have to remove, just like sewers, is the phosphate. And it's not toxic to anybody, but the algae will bloom in ponds and streams, and it is toxic, and that will kill the fish and produce toxic materials. So for our soils, the phosphate reacts with the aluminum in the soil, and so that the phosphate never reaches more than a few feet from the leaching field, and it's incorporated into the soil and bound up there. And another component we have to worry about is hydrogen sulfide. Sewers have the same problem too. Hydrogen sulfide is as toxic as cyanide, and so it's also corrosive. So it has to be removed from the system. And once again, the miracle leaching field, with the bacteria and the oxygen there, either reduce it to sulfate or sulfur, neither of which are toxic or corrosive. So let's talk about, next slide, please. Let's talk about protecting our septic system. The newer septic systems are supposed to have a projected lifetime of 60 to 80 years. That's a long time, but you need to protect it. You need to maintain it. And the first thing you want to do is pump it out every 2 years, because otherwise the sludge can build up to the point where it can go into the leaching field, and that will plug it up. So that's not a desirable situation. You want to minimize oils and greases into the septic system because they're poorly metabolized and they hang around a long time. And the other thing is you don't want to run your dishwasher, your washing machine, and your bathtub all at the same time. You don't want to put a lot of fluids in the system all at once because it stirs up the sludge and it may end up slowing into your leaching field. Now, the other thing that can happen is leaching field can fail. And there's two ways it's commonly fails. One is tree roots get in there and plug up the line. That's an easy solution. Just keep the trees away. The other one is a biomat will form underneath the leaching field that can plug up the water, and so the water can't flow into the soil below it. And you want to minimize that formation of the biomat. And the way you do that is you minimize the water and the organic material you pump into your septic system. So you don't feed the biomat so it doesn't grow or grow very large and seal off your system. So with that, you have a really long system can last quite a long time. The other thing is you don't want to put medicines or toxic waste or toxic materials into your septic system or your sewer. The best thing to do for medicines is to take them to the police station to have them dispose of it. And for hazardous materials, you can use the hazardous waste day and the town's transfer station. So thank you for listening to this very brief discussion of sewers and septics.
Thanks, Mike. Yeah, you covered a lot of information. That was great. Seems like people have to, maintain their septics, not only for their own benefit, but also just because it helps the groundwater and the environment and things like that. I want to mention a couple of other things. We've discussed several committees and government functions here in this meeting. It's worth mentioning here that there are two additional government entities responsible for our water. The Select Board serves as our town sewer commission. And the Board of Health is also responsible for, among its other tasks, is responsible for enforcing sewer monitoring and enforcing septic maintenance. I think one thing we could take away from it, and something I've learned, is the number of many government and citizens groups that take an active role in ensuring the sustainability of Acton's water. And it's something I think is useful and something I'll think about when I use my water. And again, as I mentioned, we're gonna post links in the chat. We should be doing that shortly. We're going to post links to things like the RAC and Acton Water District and Sustainability Committee and Green Acton and so forth. So if you want to grab it off of the chat now, that would be a good time. But again, we will be posting it on the Green Acton website later. And if you can just Google Green Acton, you'll go to the Green Acton website. There'll be a tab there for issues. And one of the issues in there is water. So you can go to the issues water and we'll be posting this information there. You can find other things there, like we've had a PFAS forum in the past, and 1,4-dioxane, and another one on rivers and monitoring our rivers in the area. So now it's time for our Q&A session. And so we're going to try to sort through these and direct them to the proper experts. Sure. Actually, why don't you end the presentation? Yeah. So let's start with this one. Since we have more severe storms, doesn't that mean less water gets into the aquifer since the rain won't saturate the soil, enabling percolation? Erica, why don't you take that one?
Sure. Yes, that is definitely a concern with severe storms. So when we have a storm where a large amount of rain falls in a very short amount of time. And we've had a few of those in the last few years where we get 2 or 3 inches in an hour or 2 hours. That most of that does run off because there just isn't time for the ground to absorb it. So that is definitely one of the issues with larger storms that are of shorter duration, and that is a concern over time.
So like the models that Andrea was saying, so we may get more rain, but we may have wetter seasons, but that doesn't necessarily translate to water in the ground because it flows off. Is that correct?
That's right. Yep. So what the ground likes best is sustained rain at a not too fast pace, and that gives lots of time for it to soak in and absorb. So no rain and too much rain all at once are both problematic.
Okay, thanks. Next question is statement during Lucy's discussion. I suspect that this audience does not reflect the typical or average water user in Acton. Do we have any, I don't know, Matt or Alex, do we have any data on like, is there a wide variety in number of amount of water people use, or what can you speak to that? What Alex, you want to take that? Wait, I see Matt smiling. Matt, you want to take that?
I think she was hinting at I should take it. Yeah, there is a wide variety of water use in town. So to put it in perspective, that 55 average gallons per day is all residential classified customers throughout the year. So that could be, a single person living in a 1-bedroom apartment, or that could be a family of 5 living in a 5,000 square foot house with, an acre of, manicured lawn on it. So, that single person in the apartment may use 25, 30 gallons a day. And that, family of 5 may be using, thousands of gallons a day. So there is a wide variety there based on the poll results. I do think that the subset of folks that we have here tonight don't represent a wide swath of folks in Acton, but again, that 55 gallons, does say that we as a community, are a little more mindful of our water use. So the state of Massachusetts does have, a target of 65 gallons per day. And I believe the last time I knew the statewide average, I think, was at 61 or 3 gallons per day statewide. So, Acton continues to do pretty well.
Thanks, Matt. Do you think, because just related to that, because like Kim was alluding to, that we have our own, it's our own water. So other parts of the state, they may be off of the Quabbin Reservoir and have plenty of water, and we don't. We are restricted by what rain falls in Acton. So do you think the fact that we are a little less, is that still, that's a good thing because we're maintaining our own, we are our own water source? Is that a correct thing?
Yeah, so that kind of comes down to control and people's buy-in. So I think the Acton Water District has been very proactive in getting people to think about their water and use it wisely. I'll go back to the 1980s when Acton first started doing conservation, and that was in response to the W.R. Grace contamination. So we had a real compelling reason to start thinking about conservation and efficiency. And if we were part of a bigger system, yeah, we probably wouldn't have as educated of a customer base, but because we have a limited resource, people tend to take stock in that, and events like this really help to continue that message.
Okay, thanks. A similar question, and I guess this was answered in the chat, but I'll read it anyways, and whoever answered it can answer, just so everybody else hears it who may not have been paying attention in the chat. So the question is, I just got an email from Acton Water today that indicates that the average household usage is 117 gallons per day. Why the discrepancy? Whoever answered that can.
Sure. So I answered that. And, the email that Bill was referring to was part of our Water Smart program, which Alex alluded to earlier. So customers of our system are put into this portal system where you can access your information. And one of the things that comes out of that is on a roughly quarterly basis, you get what's called a home water report. And it compares your water use for a given month. And it doesn't look at the whole town. It looks at your household, demographics. So in Bill's case, I'm going to use you as an example here. You are compared to other homes in town that are of a similar size to yours and have 2 occupants. So, when we talk about the 55 gallons per day, again, that's over the entire year. This last report was for mid-April to mid-May, which historically is a higher water use time period than other times of year. And that's why there's a discrepancy there.
Okay, great. Thanks for that clarification, Matt. That's great. We're going to switch topics a little bit. So these are some septic questions. So the question is, and Mike, why don't you take this one? I have a septic system, so I know the toilet wastewater goes into the septic, but does the rest of our water, like all the faucets in the house, also go into the septic? Mike?
Oh, what's the question? Huh.
I'm sorry. So the question is, I have a septic system, so I know the toilet wastewater goes into the septic, but does the rest of our water, like all the faucets in our house, also go into the septic?
Oh, I see. Okay, good question. So it used to be people had gray water where you take your washing machine and your sink and you put them in something other than the septic system. But now that's considered illegal. And so everything goes into the septic system.
Oh, okay, great. Another septic question, so don't unmute or it's a comment, not a question. Those with private septics may know that if it's yellow, let it mellow. Okay, that's some good advice for water conservation there. So that's conservation, not efficiency. Is that right?
Yeah,
Alan?
there you go.
So another septic question, where the population density allows it, are septic tanks a more sustainable selection than town treatment plants?
Oh, so what's more sustainable, sewer or septic systems?
And
I think they're pretty much equal.
Sorry, they specifically say where population density allows it.
Okay.
Yep.
So, yeah, exactly right. So, if you have, half an acre or more, you can put a septic system on it. But if you have a higher density, you can't maintain a septic system and you really have to go to sewers. But they're both maintainable as far as operation goes if the density is appropriate.
So I guess, and maybe I didn't read it correctly. So let's say you did have the half acre, right? And the town was making a decision between septic and sewer. Are septic tanks more sustainable in that case? Like if the choice of going with septic tanks, would that be a more sustainable choice?
So it's a difficult answer to make because sewers usually are more expensive than septic systems over the long run, even when you have to replace your septic system. Now, if your septic system does 60 to 80 years, it's unlikely that you'll even worry about replacing it if it's a new system. So it's a bit tricky. Now, of course, the sewer, our sewer, for example, needed $6 million to upgrade it. And so to make it sustainable. So you have to put money in both systems to make them work.
Okay,
I
great.
seem to have a question.
I'm sorry.
Oh, Matt has his hand up. That's how
Oh, okay, Matt.
Yeah, I just wanted to add another point to that. I think, Mike, you were, kind of talking partially about the financial sustainability of it. But I think also, two things to consider, when we talk about sustainability, all of the water, regardless of septic or, the town sewer, is coming back to the aquifer, which Erica discussed earlier. And I think, relative to sustainability, that's an important thing to keep in mind. The other piece of it, would be what unintended consequences are there from, relying on, septic systems versus a treatment plant of some sort, whether it's the town or a package one. As we learn more about, how certain contaminants move through the environment, the sustainability of a septic system maybe, less desirable going forward than it once was thought, because they don't remove contaminants, whereas there may be a better opportunity to remove contaminants from a controlled treatment plant. So that's another thing to think about, not just what historically have we thought about sustainability in wastewater, but what about the future, and what are the cascading impacts of those decisions.
Okay, thanks, Matt. So here's a little bit of a different topic. A very good question here. Are private wells for garden use a wise idea? It depletes the aquifer, but puts smaller demands on high quality potable water. Erica, you want to take that one?
Sure. So this is sort of a mixed bag. Definitely it does lift some burden off of the treatment system, which I think folks talked about in terms of the more water we have to provide. It shortens the life of our infrastructure. We have to provide, make more water for everybody. So in that respect, it can be a good solution. But a drilled well does take water. In this case, probably you would be drilling a bedrock well, which is not necessary. It's not the same sand and gravel aquifer that we pump out of. It's below that in the bedrock, but ultimately all those systems are connected. So you can potentially be depleting over time. One individual house, not a big deal, but when you get many people doing the same thing, you could potentially have a problem where you do start to deplete the bedrock aquifer over time. So a private well is not necessarily a good long-term solution. Conserving water, gardens definitely use less water than lawns. So drilling a private well to water your lawn is probably not a great sustainability solution.
Okay, thanks, Erica. So we have a couple of questions here about condos. Is there anything being done to educate condo associations regarding reducing use of pesticides and herbicides? Alex, do you know anything about that, or Matt? No. Well, is there anybody from the health department here? Do we know that might be able to answer that question? Or
indirectly, we kind of encourage that through some of our, landscape management, resources. We're not targeting at any particular, customer group, but we do try to, encourage people to put sustainable landscaping in that doesn't require a lot of effort. I know, probably 10, 15 years ago, there was a regional effort called Healthy Lawns for Healthy Families, which was a consortium of local water suppliers and conservation commissions and sustainability groups in like a 15-town radius. And we did do a lot more effort around that, but I'm not aware of any active kind of outreach on that topic currently.
The town of Acton, so the Department of Public Works is tasked with doing a lot of outreach around things like pesticide, fertilizer use, to try to reduce the amount of pollutants and try to reduce the amount of pollutants, stormwater runoff carrying pollutants. So they do outreach through the municipal monthly, which is the newsletter that the town sends virtually. And then they also include it in the tax bill. And then there's some information on our website. But in terms of directing the outreach to condos, I don't believe it's been that directed.
Okay, thanks, Andrea and Matt. Another kind of question here. And I see it was answered in the chat, but again, we'll just read it, and Alex answered it, so we'll let you answer it. And it's a good question. Are condos included in the efficiency evaluation program? Alex, you want to take that?
Yes, so we just specified that they're for residential customers. We didn't specify it had to be a single family. So condos are certainly eligible. If anyone on the Zoom is interested in scheduling one, feel free to contact me. You can email me, alex@actonwater.com. My email is also in the chat.
Okay, and if anybody's on the phone, it's Alex at Acton Water, all one word, Alex at actonwater.com for that. All right, back to a sewer question. Mike, who owns and operates the sewer treatment plant off of David Road next to the Bruce Freeman Rail Trail and the Shovel Brook? What does it service?
So I'm not for sure. Is this the Adams Street sewer plant? Or
Yeah,
not for sure. I can't address that question very well, I think.
It's one of the
Maybe-
package plants off of Davis Road. It's not David Road, it's Davis Road.
oh, Davis, yeah, maybe
Yeah.
David. Yeah.
But I don't know who it serves.
So is that Kim? So that's like a private, like for like a local community or local
It
building.
would be for a local development, yeah, but I
Yeah,
don't know more specifically than that.
right. So it's probably probably private.
I think so, but I'm at the edge of my knowledge here. Erica knows more than I do about the local sewer plants, but probably not that specific one.
Yeah, that one is private. So if you're not familiar with the Davis Road area, there's actually pretty dense development. There's condos, apartments, there's dense single family homes and townhomes. So it kind of serves some combination of those, but I'm not sure exactly which complexes feed into that.
Okay, thanks, Matt. So this next question is more of a comment, and I'll just read it so everybody can hear this. And Erica responded with some information. So it says, "I don't think the police station accepts unused medications anymore." This is in reference to putting medications down down the drain. So they sent me to CVS last time I tried to leave them at the police station. What should I do? And then Erica responded in the chat with the FDA link to find drug take back locations. So we'll put that on the Acton website. We'll put that information there for people.
I would just add that there are also periodic events. So maybe 1 or 2 times a year, there's these National Take Back Day initiatives, and there'll be more locations on those days than there would normally be. And those are usually advertised. Often there's something in the paper or on the state website about that.
Okay, thank you. Thanks, Erica. The next question is a short question. What about pool use? I assume that means in terms of consumption. Alex, do you want to talk about that, or Matt?
Sure. I mean, we certainly have customers who have pools. That would be something that if you are on the WaterSmart platform, you would be able to update your profile to let us know that. So we do have the ability to kind of look at demographics of those who would have swimming pools. But yes, that would certainly go into that overall calculation of residential water use. It's all metered the same. It all goes through one meter.
Okay.
Yeah, one just note on that, we did talk about kind of the changing climate. And one thing that we have seen over, probably the past 10 years is customers that do have pools are filling them, topping them off a lot more frequently than they used to, because we are getting longer periods of high heat and dry weather. So we actually have been seeing quite a bit of increased usage around pools. And, here in the Northeast, we haven't really gotten in the habit of encouraging pool covers. But certainly if we continue to see weather patterns change, that may be something that you hear the district encouraging, is the use of pool covers to reduce that evaporative loss.
Okay, thanks, Alex and Matt. So there was a question that I didn't jump on right away because it seemed like Andrea probably addressed it because it came in early, but maybe it's related. And they asked, could someone talk about how climate change has impacted Acton's water supply? So this seems more like not the future, but the past, right? And you just spoke about swimming pools. They're evaporating more quickly. Are there other areas where you've seen climate change already impacting our water supply? Matt, you want to take that?
So right now, I'm gonna say no, we haven't really seen changes that we can directly attribute to climate change, in terms of the wells. Certainly I gave an anecdote about, change in water use. But at this point, I wouldn't point to something and say, oh yeah, definitely we're seeing changes. It's also difficult to assess, what things we see in a well, either water quality wise or, water availability wise, and whether those are related to climate change. One classic one, and I know Erica enjoys talking about this, is actually the impact of increased beaver activity. And the resulting changes in how surface water features and the groundwater interact. So our wells in West Acton, we do see changes that are going on there, and I would hesitate to call that a climate change related impact. I think that has more to do with the 1996 kind of beaver trapping ban that was adopted in Massachusetts. So but there's other folks on the call that are probably much better versed than even the speakers on the panel about that. If anyone wants to chime in, I'm looking at you, Dennis LeBlanc.
Dennis, going once, going twice, if you want to jump in. All right. So I have a question here that if anybody would like, I'm not sure who's best to answer this one. So maybe you can raise your hand or just speak up. It says, what is the waste? What is the waste from water softeners, and how should it be disposed of? You might be familiar with that, Mike, or again, if nobody can answer this, maybe we can do a little bit of research and we can throw that on the Green Acton website.
Yeah, I can give you a brief, bit of guidance on that. They're not allowed to go to septic systems. So that's part of the answer, is where they can't go. Technically, they're supposed to go to, a registered, dry well injection point. And you're supposed to go through a permitting process to do that. Some people will discharge them to, just the ground, the environment behind their home, or, to the wastewater system, which there may be limitations on whether or not that particular system would allow it. But that is regulated by the state, both in their Title V, septic regulations, but also in their underground injection control program, which regulates, things like dry wells.
Okay, thanks. So another septic question here, Mike. Do extreme rain events affect septic leach fields?
I'm uncertain of that, but I have heard of cases. In fact, I do know that of cases in our neighborhood where we've had floods where the flood would raise the groundwater to the top of the leaching field, and that, of course, at that point the leaching field is failing because it's not treating the constituents appropriately, and usually the town fixes it up so that doesn't happen. They monitor the highest water level and use the either mounds or some other technique to keep the leaching field free from such an event. But high water can be a problem, especially with older leaching fields where people didn't determine the position of the water table at the appropriate time.
So was that event in your neighborhood, was that a temporary thing with a lot of rain, or was that like the water level rose overall?
Oh yeah, so in our neighborhood, for example, we had some flooding and it was temporary. It still is a problem. You don't want that pollutants getting into the soil.
Okay, thanks, Mike. So again, I think this was answered in the chat by Matt. Follow up to the well question, Matt, you commented that Acton Board of Health requires all private wells to be drilled into bedrock. Does this apply to wells used for lawn watering as well as for use for drinking water? And I guess, Matt, you replied both. So private wells just go into bedrock no matter what?
That is what the regulation calls for, yes.
Just a couple more comments. Someone put into the chat about Sunday's Acton Climate Festival and Sunday's Water Committee meeting. So 2 events going on. Oh, and Kim did put the information into the chat about the different organizations. So I think that's about it for questions. So we have about 2 minutes left, so that's great. We were concerned about this this time because we had 7 presenters presenting a lot of information. We presented a lot. Like they did a great job of presenting their information and keeping it concise and getting it down to the important facts. So I want to really thank the presenters for doing such a great job and staying on to answer all the questions. Really appreciate it, and you can see the amount of work that they do in town and all the the committees, the citizens advocacy groups, and the water committee, and the town of Acton government. It's just a lot's being done, and it's amazing to see that. So appreciate all the presenters. I appreciate everybody coming on to listen to this, and it's great for the town of Acton. Oh, I'm sorry. Someone has their hand raised. Steve Long has their hand raised. Steve.
Actually, it's not Steve Long. It's
Okay.
his wife, Joanne Bissetta. We're watching on his phone here. I just wanted to thank Green Acton, the Acton Water District, and everybody else to put this together. This is really informative. However, Steve and I were just thinking, boy, we're sort of looking at the participants and preaching to the choir, and I'm wondering how to get this really important information out to the rest of the community. And I don't expect an answer right now, but I think that's something that the town and the district and others should really look at, is how to get this information out to not just those of us who are, really, really concerned about it, but the rest of the community that are, busy with other things.
Thanks, Joanne. That's actually a great point. And so we are recording this, and the reason we're recording this, and like the other Acton water forums, we put this on the Green Acton website. And if you all thought this was valuable, then once it's up on the website, hopefully we'll do this this week. Tell your friends to watch it, and hopefully this again, this is information that should be pertinent for a long time to come. So if people can share this with other people, if you thought it was valuable, share it with other people, tell people to watch it, and then maybe that's one way to spread the word. So
Great, thank you.
Thank you all very much for coming, and spread the word, definitely.
yeah. All right. So thank you very much. Again, have a great evening, and we have a half hour to get ready to watch the Celtics game. So all right, enjoy your evening, everybody.